Right, so as you said, I'm from the University of Waikato, and today I am going to be presenting our paper on automating test scripts for Android user interface testing. So starting off very early with our introduction in terms of what we're talking about here. Here we're talking about obviously the Android operating system. I'm sure most of you are familiar with it. You're likely to have it on your phone, but it's also used for many other platforms as well. Things like TV and Wear devices. And it's used in lots of different settings these days. So there's almost an app for everything. And things that are safety critical as well are starting to use Android applications. So for example, artificial pancreas systems that are used for type 1 diabetics often are tied to an application where all of their data is gathered. And because it's safety critical, meaning that something could go seriously wrong if there's something, an error in the app, so it could cause harm to the user, it's really important that the testing of these apps is done correctly to make sure that they work as expected. This is also really important because Android is open source, so anybody can create apps for Android using Android Studio. So our focus today is on Espresso testing. So Espresso is one of the most popular testing frameworks for Android, mainly because it's embedded in Android Studio, which is where we are able to develop these applications. It's a capture replay testing tool, which means that we record interactions with the user interface of an application and then replay those interactions as tests. In order to write these tests, there's a couple of different ways that we can go about that, and I'm going to talk through some of those options over the course of this talk. But in general, we have to create some kind of test script, and it needs to be in either the Kotlin or Java programming languages. Once that script is run on the user interface, we get some output from the tool that either tells us that the test passed or that there was an error with, a stack trace and all the things that you would expect to see. So in terms of different types of capture replay approaches, there's three main ones that we're going to cover. The first one being recording. So in a recording approach, a user will use a capture replay tool to essentially perform actions and record them as those actions are performed. And then usually the tool will generate a replayable test script. So this test script can then be played over and over again as changes are made to the system under test to ensure that it continues to behave as we would expect it to. So this is very much the approach that you can take with Espresso. So if we have a look at this video here, what we've got up is the Espresso recorder within Android Studio, and as the users start to click on different elements of the application, in this case on a emulator, but you can also do the same thing with a physical device, you can see that the recorder starts to record those tests and what inputs the user is adding to the system. So you can also add, you can see there it's got the add assertion button, so you can also add specific assertions, so input outputs as test oracles to ensure that specific data is being viewed on the screen. And then once all the recording is finished, so once we've gone through and put in all of the information that we want for this particular test, the recorder will then generate a test script in either Kotlin or Java, depending on what programming language you've set it up to work with. So I'm just going to move on from that one. So once that's been recorded, we can then replay these tests. So in this video here, you can see some of the tests being replayed on the emulator here. You can see that as it's running through interaction sequences, the application keeps being reopened as it tries to do different tests. We can see some of the output coming up over here on the side of the screen, telling us whether the tests have passed or not. And essentially what we will want to see for this particular one is that all of the tests execute correctly, that we haven't run into any input errors based on the assertions that have been put into the test script. So obviously we can have multiple tests executing at once, which is really good because it means that we can build lots of different test suites for different interfaces within the same application. So if we think about the process that we've just seen, recording with Espresso sort of in its traditional sense, we capture some tests by recording them using the Espresso recorder. That then generates some scripts which we can then replay to ensure that the tests are executed correctly. The problem with this process and the motivation behind this work is that the test scripts that they generate are incredibly verbose. So you can see in the screenshot here of the to capture the first few lines of the test that was generated, but it ends up creating hundreds of lines of code, sometimes just for one simple test, because of the way that the recorder is set up and recording those interactions. One of the other things that we encountered when we were using this tool was even though you would sit down and go through this process of recording these tests and getting them all set up in the suite correctly, the generated scripts were incredibly fragile and prone to breaking. And so what would happen is you would sit down and record all of the different tests and then you couldn't rerun them, essentially, which is kind of the point of having a capture replay tool. It's in the name, right, that you can replay these tests over and over again so that you can essentially take a regression testing approach. So essentially with this particular test that was generated here, if we try and run this again, it will give us build errors and it will just not run at all. And because it produces these hundreds and hundreds of lines of code, it's really hard to work out exactly what is causing the build error or what is causing whatever error has prevented it from running. So it makes it really hard to maintain the test suite. And this is just one example of the fragility that we saw with the Espresso tools coming from the test recorder. So building on that concept with test fragility, so as I said before, it occurs when tests break and can't be reused. The reason that this occurs with the Espresso tools is because the scripts that they generate are very tightly coupled with the user interface. So depending on the structure and how well the layout of the interface has been created by the developers, if you make a very small change to that, I don't know, to refactor or make it look slightly different, it will result in errors in the tests and then straight away they're broken and you can't rerun them. So what this actually means in practice is that the person that is executing the test, so the tester, would need to re-record all of those tests, which means it's time consuming in terms of being able to actually use the test tool as it was supposed to be used. So one of the things that we can see from looking through this process is that the replay part of Espresso works well. It's the recording part where the issues are occurring and that they're generating these test scripts that are unreliable. So another approach to capture replay testing you can also do with the Espresso tool is taking a script approach. So in a script approach, a test will be written by a tester that is then replayable. So essentially it's skipping that first step and taking away the Espresso recorder. So with the Android Studio in particular, this means that someone has to come along and write each of the different scripts in either Java or Kotlin, and then make sure that these execute by replaying them and using Espresso. So if we look at the diagram that we had before, we've essentially missed out that first step. So we have scripts that we write and then we replay them. the problem with this is that, oh, we're going to go to our next slide. Nope, it looks like it's frozen. Give me a second. Let's try that again. It does not want to work. Okay, hold on. My apologies. My laptop's now decided to have a bit of a hissy fit in the middle of a presentation. Let me try this again. Right, that seems to be working, but if I present it, it dies on me, so bear with. So essentially, we still have this problem with test fragility, right? It still occurs because the scripts that are being written by the tester, now they're being written manually, which means that instead of spending the time recording the test scripts, you have to write them. So it's still time consuming, but also it's still tightly coupled to the user interface, meaning that we still run into that same problem where if errors happen, we have to go back and rewrite all of these tests. So in our approach, we talk about using model-driven development. So what is model-driven development? It's essentially allowing us to create models of a system based on its requirements, and use those models to develop the implementation, perhaps generate some code and some tests for whatever software we happen to be developing. So the primary benefit of taking an MDD approach is that it reduces the time costs in terms of the development, because when changes occur in the system, rather than having to update the implementation directly, we use those models to then regenerate things like tests, and this results in less debugging and error fixing. So ultimately, we end up with software that is easier to maintain. So in terms of capture replay, this is a generation approach, in which we're able to use some kind of model or specification that allows us to automate the creation of the capture replay test scripts. So when these small changes occur within the user interface, instead of having to rewrite them or re-record the tests, we can simply regenerate them by using the models. So this is the approach that we proposed in the paper, and essentially helps us to address some of those issues that we have described earlier in the Espresso testing tool. It also addresses some of the test fragility because we're now decoupling the generation of the tests from the UI and putting a focus on the models instead. So in terms of what this approach looks like, you can see that we've essentially replaced that recording phase by capturing by model, and then we still generate scripts from the models as well as replay those in the Espresso testing tool. Cool. So what we did was we created a tool called the Espresso generator, to keep it simple, which essentially covers doing these first two phases in this new approach, which we can then directly import into Android Studio and run the tests in there. So in the paper, we used the simple to-do application, essentially as our case study. So this is an open source application that was downloaded off F-Droid, and we had no input into the design of the application, so we were very much reliant on how well it had been developed in order to execute some tests. So in terms of what this application does, it is essentially for keeping track of a to-do list. So you might want to do things like add tasks and have an interaction sequence to do that. So in this case, what we've got here on this slide is essentially an interaction sequence of adding a basic task to the to-do list, and what we, as we describe in the paper, an interaction sequence looks like for us in terms of the way that we specify how you move through the different interactive elements, or widgets rather, on the screen. So what that allows us to do in terms of modeling is generate one of these finite state automata. So these essentially represent the interaction sequence for a specific task. So for the sake of illustrating what it looks like, we've got our edit a task sequence model here rather than our add a task. So what we've got is essentially the start state in green at the top there, and our final state in red at the bottom. And as you can see, by moving through the different states that are available to the user, we've got loops and different paths that we could take for a particular task and still execute it successfully. So this essentially allows us to explore sequences of different lengths. And that means that we can generate lots of different sequences, I should say, for a particular task. So that means that we can create multiple test cases from this one model. But of course, there's a bit of an issue, right? Because now we have a model that allows us to generate sequences that we can then use in the capture replay tool, but it still needs to be attached to the implementation somehow. So the way that we get around that is by creating this mapping. So we map the different names of widgets inside of the interaction sequence model to identifiers in the Android application and its layout. And there's different identifiers depending on the widgets and the way that the types of widgets that have been added to the user interface. And the benefit of this is that when the user interface does change, so when a small change occurs, we simply need to update this folder rather than rewriting all of the tests, which means that we can then just regenerate them based on that. So this is essentially what the generator does. It takes that interaction sequence model and the map to generate these associated tests. At the moment, it only supports the on-view and on-data functions in Espresso, but we can obviously add more function to that as time allows. So the benefit here is, and the reason that we're focused on these two functions, is that it captures the majority of the user actions that you would capture with the Espresso generator, Espresso recorder, sorry, if you were recording them directly. So what I'm not going to do here is go into detail of the full case study. The details are in the paper, but obviously if you have any questions, then please ask away. So what are the benefits of taking this approach? Well, if we compare just one task from the generator to the recorder, we had 111 lines of code for one of the tests that we use with the recorder. With the generator, that takes lines of code down to 10. So doing that for every single test that you want to create for a particular application means that the tests that are generated are much smaller, and it makes it easier to read, update, and obviously to maintain. The other benefit, as I said before, is that when those changes do occur and updates happen within the user interface, rather than now having to recreate all of the tests and rewrite them or re-record them, we can simply generate them again and then just import them into the Android Studio project. So that means that the tester only needs to make some very small changes in terms of importing and putting a few details in that to allow them to run directly in Espresso, rather than having to spend all of this time recreating them. So for future work, obviously the models that we have created need to be maintained and updated if taking a model-driven approach. But if you are doing model-driven development anyway. It doesn't really add anything extra to your development process. And of course, having models in the process means that you can do other things like verification and validation, which provides extra benefits and ensures higher software quality. As I said before, there's only a subset of different functions currently supported within the tool, but that can be extended as part of future work. And some of the information still needs to be input by the user, so adding the files directly into the project and things like that. So future research is required to investigate this further and generate scripts that can automate that part of the process. And we've also at this stage focused on valid interaction sequences, so behaviors that we expect the user to try and execute. But in order to generate a more robust test suite, we would need to investigate unexpected behaviors as well. So what happens if the user tries to follow an invalid path, essentially? So that is me. Are there any questions? And apologies for the technical difficulties there.